Hello there, and welcome to this maths class presented to you by O3 Schools Jamb App. Now, O3 Schools Jamb App is a software which you can download and install on both your Android phones and on your laptops, computers. And what it does is that it gives you, well, pretty much an exact approximation rather of your JAMB software, so that you're able to actually partake in mock exams. You can try these mock exams on your own, arranged to whatever manner suits you best, and you'll be able to tell how you can behave and how good you actually are in terms of preparation. So you're able to test yourself in terms of both speed, accuracy, your familiarity with using the computer system, and other factors that would come into play on the day of your exam. Because as you're aware, it's not just about knowing the answers, it's about knowing the answers and how you've been able to impute these answers so that they can try mark your exam and give you that good score which you want to get in your exam. So 3 Schools Jamb App has that feature, so you can actually practice as many times as you want before that exam. And as you know, practice makes perfect, and we are working just perfection here. So just get your O3 Schools Jamb App, start practicing these mock exams, and you're guaranteed to do better on the day of your exam. Now, merely getting the app and installing is not all you will need, because when you just install the app, you realize what you can do with it are a little bit limited. Now, to get full access to all the features which this app offers, you have to pay the activation fee of 2,500 naira only. A very, very small amount. If you're buying your hard copy past questions, for buying for all four subjects which you shall be writing on that day, you definitely spend more than this amount. But with just this amount, all questions, all subjects are allowed to you on O3 Schools Jamb App. And as well, like I said before, you also get the mock exam feature, making it even better. Then there are also other features in the app which will help you as a student. There's a question search feature in which you can actually search for questions by keywords. You can search for them by topics or by keywords which repeat in different questions. And as such, once you search, you're actually able to answer these questions and test yourself. You read a topic, you search out questions for that topic, and you're actually able to answer them and be sure that yes, you truly understand this topic. So there are many, many features. There are even places in the app you can get information, different schools, the courses they offer, and the subject combination you need in order to actually go to those schools and offer those topics. So Auto Schools Jamb App is very, very wide, and all the features are allowed to you simply upon payment of this activation fee of 2,500 naira. So simply install your app. Once you install the app, you can buy your activation key, and there are different methods of payment. There's pay with Google Play, you can transfer, or you can use Paystack. Any of these can work. You simply have to use the one that works best for you, and your app is guaranteed to be activated. Yes, guaranteed 100%. Just simply get your app, activate it, and you are one step closer towards getting that good score which you want and we want for you in your JAMB. Now, without further ado, let's call the topic of today. And in this class, we shall be studying sets. Now, the idea of set is actually quite simple. What is a set? A set is simply a group of, or it could be anything really, group of numbers, group of people, group of, well, anything that have similar characteristics brought together, such that we can have a set of boys, and this set will include basically all boys, while we can also have a set of girls, which will include all girls. So set is simply you look for an identifying characteristic and put them within that group. At times, we don't even need to look for this characteristic. As long as we decide this group of objects, or this group of things, this group of numbers should be in one group, then automatically they form a set. And typically, sets are written as such. Let's say if I want a set of boys, I could have boys. Then they always open it up with this. And then you could put in whatever you want inside. If I was going to name them, I could say I'm having John, then you separate it with a comma, James, comma, Jude. And automatically, that means this set of boys contains three elements. and these elements are John, James, and Jude. So these elements could have been numbers, could have been letters, they can really be anything of my choice. Now, if my set is to be empty, that is referred to as a null set. A null set or an empty set, I can see represented by phi. Once you see this symbol in a question, it means that set has no element. It is an empty set. As you look on through sets, there are other parameters over here. Now, there's something known as a universal set. Universal set is simply the giant set in which every other set belongs. That means if I go back to this my boys and girls, my universal set of boys and girls is basically, well, this world. Because within this world, that's where the boys and girls exist. But if I was to be using a class as my frame of reference, let's say I was looking at the SS3 class in a certain school, then all the students within that class belong to the universal set of SS3 students. That means as long as you belong to this SS3 class, you are in that universal set. But then within this universal set, I could not get what we refer to as subsets. A subset is a set that is being picked out of the universal set. Therefore, if within this class I decide to say, for a much cleaner example, let's try to put names for these people, yeah? And so, if I see my universal set, which is a set of people in SS3, I'm going to put their names now. And I'll start with, let's say, Ike. I have obviously an Igbo boy named Ike. Let's say a Yoruba boy named Ayo. A Benin boy named Osamudiamen. So that's an A there. Let's try an Igbo girl named Ngozi. And let's say these are the 4 members of this universal set. In that case, while this is my universal set, I could get a subset from it. Let's say I want a set of boys within this class. Therefore, this my boys set is now going to include IK, Ayo, and Osamudiamen. So as you can see, these 3 boys, they are all within this original universal set, making this boy set a subset of the universal set of everybody. And you are also it's also possible for you to get a subset of a subset. Let's say I want a subset of Igbo boys. Then that automatically means that the Igbo boy in this group was Ike. So he comes here. And so you see, this Igbo boys is a subset of the boy set, which is a subset of the universal set. And if I was then asked to find a subset of the boy set, which is the Hausa boys. Hausa boys. Well, if I look through the names, there is no obviously Hausa name there. I know that this set will be a null set. It's an empty set. There's no Hausa boy within that class. So that's the idea of sets and subsets. So the subsets can usually be written as Igbo boys is a subset of the boys set. This is not a U or a C, rather. This is more like, a U that is signed on the side. So it's a subset of the boys set. Now, if we now have several sets and looking at their interactions, we now have several other things we could look at. We can look at the complement of a set. The complement of a set is usually written as, I'm looking at the complement of a set A, then you can write it as either A with C on top or A prime, which is like having a 1 on top. Either of these could be used to represent the complement of a set. And the complement of a set simply means those values or those elements that are in the universal set but are not in that set. That means if I was to use this as my example again, then the complement of the set of boys would be those elements that belong to this universal set but are not included in the boys set. And as you can see, there's only one element which wasn't here, which is the girl. Therefore, that would be Ngozi. This is the complement of my boy set. Those elements belong to the universal set, but not to this particular subset. Okay, then we also have two very important things, which are intersection and union. Intersection and union. These are very, very important. Now, the intersection of two sets simply has to give those elements that are common to both sets. Let's use a different example now. Let's stop using these boys and say, let's start with a universal set of numbers less than 10. My universal set will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. We said less than 10. So if I want a set of even numbers and I call that a subset from this universal set of even numbers. Even numbers are 2, 4, 6, and 8. While if I just had on that random set, B, having elements as 1, 4, 6, 9. Okay. Then if I'm told A intersection B, what this means is I have to find those elements that are common to both set A and set B. And then I have to write them just once, obviously. If I look here, there's 2 here, or no 2 here. There's 1 here, or no 1 here. There's 4 here, and there's 4 here. So 4 belongs to this set. There's 6 here, and there's 6 here. And therefore you can see that A intersection B is 4 and 6. Those are the elements that are common to both A and B. However, for your union requires you to simply take everything in both sets, but for those that appear in both, take them only once. So you take everything in both sets, but for those which appear in the two, you have to take them just once. Implying I should be having, let me go in numerical order. I take 1, I take 2. Now 4 appears in both, but I'll not write 4 and 4, instead I choose just one. 4, representing 4. 6 appears in both, so I choose just one. 6. Then I have 8, and I have 9. And this is the difference between intersection and union. Intersection are simply those appearing in both. Union, combination of both, or any element that is in both, you have to take it simply just once. Now, the last key thing we have to learn about sets so that we can try answer JAMB questions is something known as a Venn diagram. Now, let's spell it out. A Venn diagram. Now, quite simply, a Venn diagram is a diagram which shows you all the information in these sets without actually giving you any ways. So a Venn diagram is used when you don't want to say the story out loud. It's going to use a diagram to show everything that needs to be known. For example, most typical Venn diagrams begin inside a square or a rectangle, and this square or rectangle represents the universal set. So everything within the universal set is going to come into the square or rectangle. Now within this, we could now have circles representing a subset of that universal set. So this is a circle. Circle, I could call it A. And I think there are just two subsets within here. If these two subsets have terms in common, then they're going to have to overlap. The circles will overlap. But if they had nothing in common, say odd and even numbers, they are separated perfectly like this. Nothing in common. But as is more common, in questions, if they have some elements in common with each other, then there's an area of overlap. What this means is, if there are 50 people in A and 30 in B, it means that some of those 50 actually belong to both A and B. Anything within here belongs to A and B. So basically, anything common to A and B is simply A intersection B in symbol form. So those are the things common to both A and B. That's where I'll put them. Things in just A are here. Things in just B are here. You see, set analysis is very simple. While those things which belong to the universal set but are in neither A nor B are simply out here. So remember, in the Venn diagram one more time, there is a universal set. Then you have the subset of those universal sets within it. If there's no overlap, distinct circles. If there's overlap, then your circles overlap. Those things in common between the circles appear during where the overlap is. Those things that are not in any of those subsets at all or belong to the universal set just appear within the rectangle. And this is simply what you need to know so I can begin to tackle your questions on that set. You see, it's very, very simple. Just keep these key details in your mind. And we are now ready to open our O3 Schools JAMB app and begin to answer questions. So, get your O3 Schools JAMB app ready. I shall tell you the question numbers and the years so you can find them. And we shall be able to work together to begin to answer. Now, my first question is from the year 1995, and this is question number 8. 1995, question 8. It says, 4 members of a school's first 11 cricket team are also members of the first 14 rugby team. 4 members of a school's first 11 cricket teams are also members of the first 14 rugby team. How many boys play for at least one of the 2 teams? There are different ways to write this information, but for now, how about represent it using a Venn diagram? Now, I know there's an overlap. Why do I know that? Because I'm told 4 members of the first 11 cricket are also members of the rugby team. If I call this my cricket set, it's going to be my rugby. Now, 4 members belong to both. Those 4 members come here where they overlap. Next, I'm told the cricket team has first 11, right? Yes. Now, however, if within the first 11, 4 belong to both, how many of them will belong to just cricket? That means that cricket only must be that total number of people in cricket, 11, minus these ones who belong to both, 4, giving me 7. That means there are 7 members who play cricket only. In the same way, for rugby only, I'm told that my rugby has first 14. So there are 14 members of that team. Now, within that 14 members, 4 of them also play for cricket and rugby. So if I remove those 14 members from my rugby only, that will give me 14 minus 4, and that is 10 members. In fact, I'm having 7 people playing cricket only, 10 playing rugby only, and 4 of them playing both. So the question says, how many members play for at least one? That means at least one means minimum of 1, well, but there's no upper limit. So 7 play for just cricket, as at least 1. 10 play for just rugby, also at least 1. While 4 play for both, also at least 1. Therefore, at least one sport, the members will be these 7 people plus these 4 playing the 2 plus this 10 also playing 1. 7 plus 4 is 11 plus 10 is 21, and that is option B. So you see, we have 21 students in this school playing at least one sport. Very, very easy. Let's move on to our second question. From the same year, actually, the exact same year, just simply the next question. After 8, we're solving question 9. This one says, if S, this is question 2, if S equals to, well, x, provided that x squared equals to 9 and x is greater than 4. Then s equal to what? If we have this now, what these numbers or letters within the brackets are telling me is that these are the properties of the set. Rather than just listing what the elements should be, they actually give me the properties and tell me based on these properties and to find what should be in the set. Now, what are the conditions? I want to find x, but x squared must be equal to 9 and x must be greater than 4. Let me start with this. X squared equals to 9. The only way to find x in this situation is to cancel the square, which is done by taking square root of both sides. Square cancels square roots. X equals the square root of 9, which is 3. Therefore, I know that x equals 3. Or if you want to be exact, plus or minus 3. But then lies the problem. As you can see, I'm told x must be greater than 4. 3 is less than 4. Minus 3 is also less than 4. That means between the two elements which satisfy this first equation, which is 3 and minus 3, neither of them can satisfy the second equation, which means they have to be greater than 4. And automatically, if nothing can satisfy it, that means I am dealing with a null set, an empty set, nothing is included in it. And consequentially, S must be an empty set. You see? And if you check our Jamb app, that is option C. Now we'll see how these questions go. It's truly easy. Simply, we found what obeys the property described, and when we found it was nothing, that meant it was a null set, which we previously stated was symbolized with phi. So that is the answer. Okay, but now we are leaving this year and moving on. This time we are heading to 1997. Question 3 is from 1997, and it is question number 7. Now this one gives me a universal set, U. It says U contains S, P, I, E, N, D, O, U, and R. Those are the elements within the universal set. But X contains X, P, E, N, D, which kind of spells out spend. Y contains S, E, N, O, U. Then last but not least, Z contains P, N, O, U, R. Then the question is, find X intersection Y union Z. X intersection Y union Z. Now, with all our knowledge of mathematics, we almost always deal with brackets first, which means I'm coming this way. Now, question is asking me to find what is in Y and Z combined without repetition. That means that, doing that over here, Y union Z, sorry, Z not X, must be, well, Y has S. So S comes in. Let me indicate it once I use it. Y has E. So E comes in. Now, both of them have N. So once I use this N, I also mark this N. Both of them have O. Once I use this, we mark that. Both have U. We're also taking one. But now, everything in Y is gone. But Z has P, which I'll add, and R, which I will add. That means the set of Y union Z is XEN OUPR. And if you remember, the question was X intersection this, which means what is common between X and this combination. Let me write X under here just for comparison. X contains S, P, E, N, D. So what do they have in common? I know right now that X intersection Y union Z must be what's common. They both have S, so S. They both have E, so I can take E. They both have N, so I can take that as well. Well, they both don't have O, so I'm ignoring O. They don't both have U, ignoring U. They both have P, so I can take P. They both don't have arrow, and they both don't have T. That means my final answer must be S, E, N, and P. So I simply have to open my app and check my options. And yes, we can see option C is S, P, N, E, which obviously is the same, just a little bit rearranged, which means that my answer is option C. So I hope with these, we are getting how sets work. Simply do whatever they told you, keeping in mind the organizational structure as given in the question. So we've seen how to use intersection and union. Now let's try one with a little bit of calculation. Yeah, so this is still the same year, 1997, but now question 8. It says a survey of 100 students in an institution. That means all the students in the institution are 100. The number of elements in my universal set is 100. Okay, so survey of these 100 students shows that 80 speak Hausa and 20 speak Igbo, while only 9 speak both languages. How many speak neither Hausa nor Igbo? Let's try this out by drawing the diagram, this Venn diagram. Doesn't have to be too big. And you don't always have to draw this. I'm using this for explanation cases. Within your JAMB, you're under no obligation to do so. But if it helps you understand better, then by all means do it. So I'm told 100 students, which means my universal set is 100. That 80 speak Hausa. Let's get the Hausa column. And this is the Igbo column. 80 speak Hausa, so there's 80 here. And 20 speak Igbo, while 9 speak both. Now that 9 that speaks both should become here. But remember, this 9 was already included within this 80. If I'm speaking both, I was already among those that can speak Hausa, which means those speaking Hausa only become 80 minus 9, which is 71. And in the same vein, if those speaking Igbo are 20 and 9 speak both, if I'm speaking both, it means I was already included the number of those speaking Igbo, which means I have to remove them to get those who speak Igbo only. 20 minus 9 as 11. So I have 71 speaking Hausa only, 9 speaking both, 11 speaking Igbo only, and an unknown number X speaking neither. How do I find that unknown number? Very simple. I know all these people belong to this universal set, implying that 100 must be equal to Hausa only 71, Igbo only 11, both 9, and neither X. And from here, simple arithmetic, 71 plus 11 is 82. 82 plus 2 is 9. 82 plus 9 rather is 91. Plus X equals 100 minus 91 by collecting like terms, and that gives me 9, which is option B. So you see, there are 71 speaking Hausa only, 11 speaking Igbo only, 9 speaking both, and another 9 speaking none of either Hausa nor Igbo. So you see, these questions are very, very easy. Just carefully follow the steps and you will get your answer. So let's see. For our fifth question, we shall be going to the year 1998, question 39. And this one comes to a diagram. we have 3 sets, and okay, this is P, this is Q, this is R, and just this part is shaded. Question is asking me to name this shaded region. Which part is shaded? Now let's try and analyze this without going through our options too much. Now this is P, this is Q. Obviously, this shaded part is common to both P and R. However, this shaded part doesn't include the part of P and R that is within Q. They ignored all the sides within Q. Just look at my options. Option A says P intersection Q union R. Well, P intersection Q should be this part common to both P and Q plus everything in R. But obviously, that's not my answer. This is where it's shaded. So it cannot be A. Option B says P intersection Q, again, this side, intersection R. Or P intersection Q intersection R is simply this small part. So that is the part common to both P, Q, and R. So again, not my answer. Option C says P intersection Q prime, which is saying the part of P that is not in Q. Now, this is P. The part of P which is not in Q is, well, everything beneath here, because this is where P and Q join. The part of P which is not in Q is everything down here. This is P intersection Q prime. Then the difference between C and D is whether it's going to be intersection R or union R. We've agreed that first of all there's P intersection Q prime. We want to know the relationship to R. Now, if I had taken a union of this and R, I would have had to shade everything, because that's how union works, what is in P and R. But instead, we are taking intersection, because this is now what is common to P and R, but not in Q. So common to P and R, but not in Q, which means my answer must be C. I do hope we get this one more time. This is the part that is in P, but not in Q, which is why I know this must be intersection Q prime. Then also the part common to what we just brought out, P not in Q, and R, which was right here. So you see, my answer is option C. And that is how you analyze a diagram from sets. Okay, let's move on. And this time we're going all the way to the year 2000 to look at question number 4. The year is 2000, looking at question 4. It says, in a youth club of 94 members, I like drawing Venn diagrams for simplicity. Youth club of 94 members, odd number of youth club is 94. This is my full youth club. 60 like modern music and 50 like traditional music. So, is there going to be an overlap? Yes, because there's a number of those that like both. So, 50 like modern. This is 50 like modern. And, 60 actually like modern. And 50 like the traditional. They were told the number of members who like both traditional and modern music is 3 times those who do not like any type of music. That means there are some people here, Y, who do not like any type at all, while there are some here, X, who like both. And what I'm supposed to know about these people is that X equals number of those who like both is 3 times those who don't like any. So X equals 3Y. But before I leave, you have to remember, if 60 people like modern and X likes both, this X was included in 60. Here will be 60 minus X. Same thing happens here, making here 50 minus X. And keep in mind that X is 3Y. So to start my solving, I know that if I add all these people together, I should be getting the universal number, which is 94. So 60 minus x, which is here. Now, plus those in common x, plus those who like traditional only, 50 minus x, plus those who like neither, y equals 94. Now, obviously, I can't solve when having, different variables within. But let's just see what happens first. Minus s plus x is 0. So you're having 60 plus 50 minus x plus y equals to 94. However, I know that x equals 3y. So I can substitute. 60 plus 50 is 110. X is 3y plus y equals 94. So minus 3y plus y is minus 2y equals to 94 minus 110 over minus 2. Let's do subtraction first. Minus 2y equals to 94 minus 110 is minus 16. So over minus 2 over minus 2, y equals 8. So there are 8 members who like neither type of music, which means that there must be 3 times 8, which is 24 members who like both. Now that I know this, let's go back and check our question. The question is, how many members like only one type? I want to find out those who like only the modern type and only the traditional type. So for those liking only modern type becomes 60 minus x. X is 24, that's 36. Traditional becomes 50 minus 24, and that is 26. And therefore, the number liking only one type must be 36 plus 26, which is 62. And that is option C. You see, 62 people like just one type of music. Okay, we are gradually getting to the end of this tutorial video. Let's just solve one more question or two, and we shall call it a day on sets. So let's see. Let's start with this one coming to us from the year 2005, question 10. As our 7th question, this one says, if u equals to x, now remember, once they put this column, they have to describe the properties of this x. I'm going to say is that x is a positive integer less than 10. Positive integers are positive whole numbers, but they want it to be less than 10. Therefore, I can fill in this set. The first positive integer is 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, they said less than 10, not less than or equal to, which means I have to terminate it at 9. 10 is not included. Then we are told P, the entire description, which is that x is a prime factor of 30. What are prime factors? It's a prime number, basically, which can go into 30. So let's list out all the prime factors of 30. Now, where 1 is not a prime number, so 1 cannot belong to this set. 2 is a prime number, and yes, it can go into 30. Implying that 2 appears here. 3 is a prime number, yes. It can also go into 30, meaning 3 appears here. 4 is not a prime number, so I don't even consider it at all. 5 is a prime number, which can go into 30. So it belongs to the prime factors. 6 is not a prime number, though it goes to 30. So I have to leave it out. 7 is a prime number, but cannot go into 30. We ignore. 8 is not a prime number, and 9 is not a prime number, implying that the only prime factors which can go into 30 are 2, 3, and 5. Consequentially, if I'm to find the complement of C, which is P prime or PC, these are those elements in the universal set Both are not included in the P set. And so the first one must be 1. I did not include 2 and 3, so I go straight to 4. I did not include 5, so I go straight to 6, then 7, then 8, and 9, which is obviously my option C. You see, it was actually very, very easy. Now, I think at this point, we should come to an end for this class on sets. However, as usual, I'd like to give you a couple questions which you can solve. And remember, when you solve, you can comment your answers underneath these videos. So if you do comment your answers, we'll be able to let you know if you are right or wrong. And if you are wrong, we shall give you ideas or steps on how to fix your mistakes. So let's try our first question from the year 2005, question 11. Also, you can go to 2004 and attempt question 43. Furthermore, you can go to 2003 and attempt question number 6. Also, you can go to 2002 attempting question 3. We have one last one for you, okay? Go to the year 2000 and attempt question 1. I would also like to state that not to prevent you from attempting any question at all within the O3 Schools Jamb App. Just try to you can comment and ask any question over anyone you've seen within the app. Just try to put it under the appropriate video dealing with that topic, and we shall definitely respond to you. So, thank you very much for watching. Remember, get your O3 Schools Jamb App and activate it to ensure your success in your examination. My name is Athanasius. Thank you very much for watching.